The purpose of this video is to remind you how to properly light a laboratory burner for use. And so we obviously have a laboratory burner. We have the striker I'm going to use to light the burner, and we have the gas jet there to supply the gas to it. Before we get started, the first thing we always want to do is to check the hose for cracks. One of the easiest ways is to wrap your hands around the hose and slowly move your hand over the hose, checking for any rough spots or holes that you might feel or jagged edges, anything that might tell you that it's not a good hose. And if you find something, you would want to visually inspect it. And if you're in doubt as to whether it is a crack or not, please ask your instructor to check it for you. You want them to make that decision, not you. So I've checked my hose for cracks, and it is connected to the gas jet there, and it is connected to the burner here. And yes, I know that that's like not over all the little tabs there, but it doesn't have to be. It just has to be connected enough that if I were to give a little tug, it stays on, because that's all we need. The gas does not come out of the jet with much force, so it's not like you would see in cartoons where if that let go it would start flying all over again. The hose would actually just lay on the table because the hose itself is heavier than the force of the gas coming out would be able to move it. Now, our burners have two movable parts. Most burners do. There is the column here, which pivots right here, so you can see if I twist the entire column I can turn it, and what this does is it affects what I call the windows. These are vents that allow air from around the burner to get inside and mix with the gas before it's burned. To light the burner, you want those windows closed, so I'm going to twist this until I do not see any gaps anymore in those vents. Okay, I'm not cranking down as tight as I can because you know what, you would defeat the purpose of it. You're going to open them in just a moment, but I want these closed before I light. And then down here we have a gas control valve. Guess what that does with a name like gas control valve, right? The gas control valve works like any other screw mechanism in that the left is loose, so turning it counterclockwise, that is to the left, is loose, and turning it clockwise, that's to the right, is tight. Here's the problem. That works if you're staring at it, but I want it down on the table. So it's going to take practice just to know whether you are turning it the right direction. The hope is you would notice a change in the size of the flame as the gas control valve controls how much gas is out of here. It's going to control the size of the flame. And you'd also notice to open, the valve itself is moving down towards the tabletop, and to close, the valve is moving up towards the rest of the burner. To light the burner, you want the vents, the windows here closed, and you want the gas control valve open. There is no like open or closed indicator, so just have it open to some amount, and you can always adjust it in a moment. So I've checked my hose for cracks and cuts and jagged edges and other things like that. I have my windows, the vents here closed. I have my gas control valve open. I'm going to be ready to light it with the striker. I'm ready to turn on the gas there at the bench. Oh wait, let's be safe. Before I mess with a burner, anytime I'm going to be messing with fire, I want to be wearing goggles. So I know you can't see, but I'm going to be having goggles on as I light the burner. Over here at the bench, the valve actually has a safety built into it that makes you have to pull upwards on the valve before you can twist it. So if you're sitting there going, it's not turning, it's because you're not lifting up. So I pick it up and I turn it. It might turn one way, it might turn lots of ways depending on what it is, but remember, perpendicular is closed, parallel is on. If the handle is perpendicular to the tube the gas is going to come out of, that's closed, that's off. If it's in the same direction, that's on. I've had students literally go, well, if this is off and this is on, then this is on even more. Well, no, you've just made it perpendicular again and you've just turned it off on yourself. So I've turned on the gas at the bench. I have my gas control valve open, and I know it's open because I can hear gas coming out of the top. That's the test for gas, whether or not you have it open enough. You want to do the listening test. So literally, like, pick it up and put it to your ear, and I don't know if you can hear it on the video. Okay, hopefully you heard that, but you put your ear to it, and if you don't hear anything, open the valve here more. Now that's on open all the way. That's on full. It's down here that I am controlling the valve and the flow of gas. With gas coming out and the vents closed, I am ready to strike it, and I am going to pull back my sleeves for safety. And I'm going to be using the striker, which is where you just squeeze it, and that flint rubs against that file to make sparks. But it's not designed to make sparks unless you're putting pressure on the back. So yes, I'm going to put pressure on the back of the head with my left hand because I'm right-handed. If you're, the other way around, just flip. And I'm going to stick that over the burner, and I'm going to push, squeeze, and then pull back like that. And it might take a time or two to do that, but if you're putting enough pressure, and okay, if you have a good flint and you're putting enough pressure, the spark will be made and you'll light the fire. And you'll notice, yes, my left hand was in the fire there for a moment. You know what? It's just fine. Didn't even lose a single hair off my fingertip, so we're good there. And if you really do believe I have hairs on my fingertips, that's something you should ask a biology teacher. But anyway, the good news is I get a flame like this. It is considered a cool flame, not that hot. Still hot enough to catch things on fire, but really not super hot in that I'm going to be burned right away and have issues. Okay, this is the time I can adjust the size of the flame. How do I adjust the size of the flame? With the gas control valve. So check this out. I'm going to make it smaller by closing the valve. It might take a while. There we go. See, smaller, closing. I can make it larger by opening. All right. But still, this is not a good flame for heating. So our final step is to prepare this flame for heating something. So with gas open, gas valve open, and gas coming out and burning, I'm going to open the windows, the vents down here. Now notice I'm not grabbing it up here anymore. I'm grabbing it way down here. I'm going to twist this open until I get a very nice defined inner cone. And this might be rather difficult to see in the light, but we get a bright blue inner cone and a light blue outer cone. Right above the inner cone, right here, is the hottest part of the flame. Gee, that might be a test question. Right above the inner cone is the hottest part of the flame, so you want a flame that matches the height of what you want to heat so that your thing you want to heat is right above the inner cone. This is a really, really super hot flame. I would never want to brush my hand through this. I'd never want to pass a paper through this. I'd never want my hair to get through this. That would be bad. This is really, 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 really hot. And don't try to find out how hot it is by sticking a thermometer in there. That is just flat out stupid, and you very likely will break the thermometer and injure yourself. You should be wearing goggles, but there's a lot more of your body that would still be unprotected and could be injured. So this is the flame to use for heating. Now what if you're done heating, but you need the burner for later in the lab? Well, if you're going to have the flame still going, but you're not using it at the moment, please keep it orange by closing those windows so that others around you can see that it is there. And when you're totally done, you think the lab is over, you're done with the burner, you don't need it anymore, check this out. I am not going to close it off down here. I'm going to close it off at the bench. Because watch what happens to the very top of the burner as I close it off at the bench. Did you see that little tiny flame still burning in there? That was the gas that was still in the hose, working its way through the hose into the burner and burning off. What if I closed it here and then closed it off there? It would trap gas in the hose. And then the next time I go to use the burner, or when I take it all apart to put it away, that gas could escape into the room, and if there's other flames in the room, we could have an issue with having gas randomly in the room. Okay, so we're done with the lab. I've turned it off properly at the bench. What should I do with this stuff? Nothing. I'm going to let that cool until it's cool enough to touch. I certainly do not want to put a hot burner away into cabinetry, especially not like wood cabinetry. That would be really bad. So just leave it alone, walk away, let it cool until it is cool enough for you to touch, and then you can put it away. All right, so that's the steps. This is my expectation from you in class, that you know how to do these steps, and you're going to prove it to me later. But if you're watching this video, either you missed that day and are needing to watch this video to make that up, or you just forgot and you need this video as a refresher. Either way, this video is here for you. Watch it as often as you need to. Really useful piece of equipment. Could be a really dangerous piece of equipment. Please use it properly. Good luck.